In this section, we're going to take the code that we used to generate an empirical sensitivity measure in the last screencast, and we're going to roll it up together into a function called sensitivity, which can take any query and empirically measure how sensitive it is to removing people from a database. The first thing we want to do is we want to copy the code that we created before. So this is what generated a database and created a parallel database to that database. Then we're going to copy our sum query. We're going to copy the line that actually queries this database, and then how we calculated sensitivity. Let's go ahead and change this back to max distance. Perfect. What we want to do here is really just consolidate this code into a single function, which accepts this query function as an input parameter, and then returns the sensitivity of this function. And as mentioned last time, this is empirically measuring sensitivity. The idea here is just to get a sense and intuition for if we were to actually remove people from a database, how much would the query change? But in the real world, we can typically know about sensitivity through other ways. So let's do this. Def sensitivity. And we're going to accept two parameters. One's going to be the query, which is a function object. And then the next is going to be the number of entries in the database that we want to query with. So here, we're going to replace this 5,000 with this in entries variable. Then we're going to query the database that we created, calculate the maximum distance from the full database query and every parallel database, and return this max distance. Let's calculate sensitivity of this sum function. And as we saw before in the previous video, the sensitivity is 1. Now let's change this function. Let's cast it to a float, and then let's calculate a mean. So as you know, a mean is just a sum divided by the number of entries. So we should expect that whereas previously our sensitivity was 1, because we're dividing this by a number, this should become by a large number. This should decrease sensitivity quite significantly. And as we see here, it truly does. So the sensitivity, the empirical sensitivity here is 0.0005, and this corresponds to the average value in the database. So this is typically returning something like 500 or something near 500. So the average value here would be 0.5 divided by the number of entries, and this is what's getting us this notion of sensitivity. Now, since this database is randomly generated, if we ran this sensitivity a bunch of times, we'd actually get numbers just above and just below. It would approximate the true sensitivity, which is really what this sampling does. But as it happens here, it tended to line up with the exact sensitivity of this function, and this is pretty great. So the nice thing about this convenient function here is that we can pass in arbitrary functions, and we can sort of empirically get a sense for how much the output of this function changes when we remove a person from the database. Now I want to go ahead and discuss and really dive a little bit deeper into this last assumption here. In these databases that we're creating, so let's go ahead and just pull this out here so we can see a database. Let's create one of size 20. In this database, every single one of these values corresponds to a different person, or we're sort of assuming this, right? So when I'm removing someone from the database, when I'm calculating, every parallel database, my assumption is that none of these are accidentally referring to the same person, right? Because the notion of sensitivity is not about how much the function changes when we remove a value from the database. It's about how much a function changes when we remove all values corresponding to a person from the database, right? We care about the sensitivity to people, not necessarily the sensitivity just to individual values. Now, it so happens that that's the same thing in these databases that we're using right now, but I really wanted to call out this notion just so that you get a feeling for what we're really trying to calculate here. What we're really trying to calculate is how much the output value from this function is using information from each individual person in the database, or is it only an aggregation of information that actually multiple people are contributing? And we'll find that it's a lot easier to protect privacy if the information that's being returned from our query, the output of this function, is actually information that multiple people are contributing to, right? So we might say an intuitive measure here might be threshold or various other functions which have a much smaller sensitivity profile. And in the next few sections, we're going to explore functions like this. So I'll see you there.